Hey there, my name is Ben Rodney from ASHRAE New York, and I want to welcome you to this episode of the ASHRAE New York Designer Series and the brand new ASHRAE New York YouTube channel. We'll be bringing you educational content, interviews, and chapter updates, and it'll be open to members and non-members alike, or anyone just interested in the HVAC industry or updates on our chapter. You can find us on LinkedIn, Instagram, and make sure to go to our website, ashraeny.org, where you can sign up for our newsletter, check up on chapter events, and hopefully even join us as a new member of the chapter. If you like what you see here, make sure to hit the subscribe button below this video and then hit the bell to get notifications on any future updates to the channel. If you have any comments, questions, or conversation about this video, just leave them in the comments section. Thank you and enjoy the episode. All right, good afternoon, everybody. My name is Ben Rodney with ASHRAE New York, and I want to welcome you to episode 4 of the Designer Series. We're so happy you could join us. The first 3 have been a great success, and I just wanted to thank everyone for taking the time to support our chapter, ASHRAE New York. I know that taking time out of your day and spending money on these things is not always easy, and to know that your dollars are definitely going to help support chapter operations, scholarships, research, and promotion at the national level. So we just, from the entire board of governors, we just want to thank everybody for your support. Episode 4 today will be presented by James Coleman from JB&B on smart buildings. You can see on the screen here, we have some future meetings coming up and events. On next week, on Thursday, we have fan fundamentals presented by Steve Sadowski from Loring, which would be great for any younger engineers or anyone just getting started in the industry or refreshing your own knowledge of that topic. And then disaster preparedness and case studies by Anthony York from Cisco and Hennessy. So make sure to go to our website, ashraeny.org, to check out those events and sign up. And you can also, one thing that we just launched and will be available for you after this presentation is our ASHRAE New York YouTube channel, where we've posted all of the presentations from the designer series, as well as the last 2 chapter meetings. And then this presentation will be available up there as well. So just go to YouTube and search for ASHRAE New York, and you can find those presentations, some great material, as well as interviews with some past presidents that you might find very interesting. Just some items for this particular presentation. So if you have any questions for James or Gab or John, just put them in the questions section of your GoToMeeting. And then at the end, I will announce some of those questions for them to answer. This is worth 1 PDH, and at the end of the presentation, there's going to be a survey that comes up. You have to fill that survey out so we can get the proper information to submit to PI. To make sure that you qualify for the PDH. So please turn off your pop-up blocker as well, because we've had some issues with that, people not being able to fill it out. The certificate will be mailed to you or emailed to you after the presentation, hopefully by tomorrow. So that's about it. So I'm going to turn it over to James.
Awesome. Thanks, Ben. So show my screen here. All right. So thanks for joining us today, everybody. My name, as Ben mentioned, is James Coleman. I am a smart buildings specialist at JB&B, where I help our clients develop their smart building ambitions and goals, and then determine from an integration perspective what it's going to take to actually achieve those. I'll be joined today by our Director of Smart Buildings, Gab, and John, who's an associate and controls expert, who can answer any questions that I might not be able to. So I've got a background in IoT development for smart building applications, and I'm thrilled to be here today to talk to you about this topic. Without further ado, we're going to jump right in. So first of all, there we go, sorry. Sorry about that. All right. Yeah, so like I said, today we're going to be covering smart buildings. Specifically, this is an overview, so we're not going to dig super deep into any particular topic, but really the objective is to cover the overarching concepts and considerations that you should be aware of as you go down the path of designing, specifying, and building, as well as operating your smart building. So the specific objectives of this talk are to, one, you'll be able to identify what it is that makes a building smart. There's a little bit of ambiguity around this term, which is not really warranted, but we're going to cover what it means to be smart and give you that vocabulary. We want to make sure that you're able to articulate the value of smart technologies to different stakeholders. And there's, of course, different values for different stakeholders, and hopefully there'll be some clarity on that. We're going to understand the roadmap to design and specify smart building, looking specifically at how that might differ from traditional project delivery. And then, given my background in IoT development, there's a call to action around standardization that will be excited to talk to you about. So first of all, what's what we're going to be covering. We're going to go into what the heck a smart building is in the first place, what's the value argument, looking at specific use cases, starting there and then moving to what the technologies are. Smart buildings are not about employing technology for their own sake. It's all about understanding where the value can be driven, and then selecting the right technologies to do that. After which we're going to go into the delivery roadmap, and like I said, looking at how that differs a little from traditional project delivery, and then cover the role of standardization. And time permitting, I will briefly cover a best-in-class smart building as a precedent. So first of all, what is a smart building and why should anybody care? Like I said, they go by a couple different names. Know that there's not really a difference. You're going to hear them called smart buildings or intelligent buildings, digital buildings, connected buildings. It doesn't really matter. The core concepts are the same, which is that it's all about leveraging digital technologies and IT standards to optimize experience for all of your stakeholders and improve operating efficiency. So when figuring out is this a smart building project, or just trying to identify what are the characteristics or attributes that makes a project smart, the first point is that a smart building is all about data. So they gather, manage, and act on data to enhance building performance with specific goals. And we commonly see those goals as being health, and this will be especially true going forward as we start going back to work with the COVID-19 situation, comfort, productivity, sustainability, and then cost savings. Two, as much as possible, we always encourage that if you're trying to deliver a smart building project, your life is going to be made much easier if you're able to do that over a converged OT operating technology and an IT network. This is going to simplify not just the design, not just the building these two networks and the integrations between what historically has sat on one or the other, but also making sure that things are secure over time and simplifying the management of these two, this now combined network as the building is occupied and used. And then a smart building at its core is going to adopt open, non-proprietary communication protocols, which one, in terms of the implementation phase, ensure interoperability, and then day two, make sure that things are maintainable and flexible and that you aren't locked into one particular system, such that 5 years down the line, we can easily make adjustments to our solution. And then finally, a sort of core theme in smart building design and development and operation is horizontal interoperability, which is to say that data generated by one building system should be available for use by all the other ones such that our whole building performs better. So why should you care? First of all, building occupants are simply demanding better experiences, whether it's at home in sort of with a smart home precedent or in retail. People are seeing the value that connected experiences can make in the spaces they use every day, and they want to see that same quality of experience in say their work environment or in a healthcare setting. So before COVID-19, offices were getting increasingly dense, so there was a push to ameliorate the condition of working in what is really kind of a suboptimal work environment, which is, say, open plan, high density. And then, especially in New York, where office space costs so much to rent or buy, that people really want to see that they're getting the highest returned value from each square foot of their building. And then post COVID-19, and even before we say have a vaccine but are going back to work, tenants are going to be demanding that there's a clear picture of exactly how their building might be impacting their health and wellness, and as well, from a design perspective, what solutions the building has implemented to keep them safe, and then provide assurances that these systems are continuing to protect them. And then also in sort of the New York context, there's a carbon-based energy economy on the horizon, and both landlords and tenants need to understand with a fine grain where they're spending energy and how they can optimize and economize. So we're going to start with the value argument, like I said, as opposed to, say, technologies, because smart buildings are not about specifying technology for its own sake. It's about driving improved experiences and improving efficiency and delivering on business objectives. So the main thing to remember in terms of how you articulate the value of smart building technologies is that every stakeholder stands to benefit differently. So a sort of core consideration when you're designing and specifying a smart building is understanding the needs of each of your stakeholders and understanding their goals, and then figuring out how you can deliver on those through increased interoperability and transparency in building systems and advanced controls. So if you are on your team, if you're advocating for the adoption of smart building technologies or the associated workflows, one of the things that's helpful as you begin to figure out who has what goals is figure out where there's overlap. A lot of smart building technologies don't benefit one group specifically, but say have the opportunity to benefit several at the same time. So, these are going to be the areas where it can be very valuable to focus and draw support such that things don't get value engineered out later. So what are the use cases? I've been sort of categorizing things into two umbrellas, the first of which is optimization, which has sort of a component of visualization as well, and then enhanced experiences. When we talk about optimization, it can take on a bunch of different forms. Energy and carbon optimization is, of course, one of them. Communicating the state of the building back to tenants is crucial, and as well as operators, and this can be accomplished through dashboarding. Analytics takes data communication and presentation one step further. This is leveraging the data we have to drive knowledge and insight, which can help people run buildings better. And one specific form of analytics, which is central to smart building operation, is fault detection and diagnosis. It's leveraging that mountain of data we can produce, and then extracting actionable insights from it. From an enhanced experiences perspective, it's especially important going forward. There are healthfulness and wellness outcomes that we can achieve with smart building technologies. We can improve comfort, performance, communication, insofar as, or rather what I mean specifically is how the building is performing and how that is enabling an improved an experience for the tenant. And then seamless experiences, and one that we see commonly is seamless visitor, or rather a common ask is for seamless visitor control and delivery. So the first analysis and sort of optimization category I want to cover is optimizing for energy use, and specifically one that we get into at JB&B is start time optimization. So this is all about pulling and trending your, say, weather data, your room temperature, as well as the set points, understanding how those interact over time, and potentially developing a model which we can implement in the actual BMS to say, hey, when the exterior conditions are this, then we know it's going to take about this long to hit all of our set points throughout the building. And the key idea being, we don't want spaces sitting chilled for hours before people get there. And then likewise, we also don't potentially want set points being hit too late, which I can speak to specific experience of. I used to work in a building where every Monday we would arrive and it was like 67 degrees inside, and it would take like an hour and a half until it hit the desired temp. So we worked with the building operator to make sure that we were happy as tenants, but sort of an inverse application. Another optimization which was popularized by micro-leasing companies like WeWork is optimization of space use and spatial utilization analysis. So this is all about leveraging potentially existing occupancy tools you have in your building already, or we're already going to specify, say the motion detectors from your lighting or security system, and then perhaps supplementing that with something with a more fine-grained ability to count people, such as an actual people counter, which can be done through several different means. But basic idea here is we leverage the use we leverage an understanding of the use of the building over time and across the floor plan to know which spaces are used and when, and which spaces potentially are used more than others, such that we can deliver, such that the tenant can deliver more of the high demand spaces by converting some of the lower demand ones. And if we've built those first two integrations out, then we have much of the raw materials to engage in some sort of dynamic controls using real-time feedback. So for example, if I know when my spaces are being used, like I said, through occupancy or detection or some other metric, then there's an opportunity to say, hey, the space hasn't been used in 30 minutes. I looked at my Outlook integration and I don't see a meeting scheduled for another 90 minutes. Let's roll the temperature back a couple of degrees and save a little bit of energy and money. We can also take this a little bit further and say, if the space hasn't been used for a little bit of time and there's, say, only 45 minutes left in the occupied part of the daily schedule, then you know what, let's just put the space into unoccupied mode and save some energy further. I also believe that with the fine-grained understanding of when people are using the space, this can be a tool to hand back to building operators to perhaps give them a more clear understanding of when the building gets used. I think probably everybody's been in an office which has where we've heard the ventilation rattle off when people were working, just because the operator doesn't have the same doesn't have a sort of fine enough grain understanding of when people actually use the space, and recognizing that's kind of dynamic. And if we've built in the required integrations to do dynamic control, then we're well set up to implement app-based or software-based controls. So we can potentially control much more than just HVAC, including lighting or whatever else. But the basic idea is, if I've already done the work of making sure all of my systems can take dynamic instruction, not just say schedules, then the lift to sort of implement app-based control isn't that much, or isn't that high. So, and if I have, say, built out all the required integrations to support app-based control, then we really create a opportunity to control not just HVAC or lighting, like I said, but potentially all the rest of the sort of parts of the building that touch my occupants. So this could be shades, or it could be sound masking technologies, and sort of putting the control of the building right in the hands of the people using it. And like I said, if we've already done the legwork to set up the first couple of integrations, and there's not a ton of work here. We're seeing, of course, tenant apps are being asked for more and more, and just understanding what the steps are to deliver those is important. Further, it sets up a question which we need to answer, which is who should be able to control what systems and when. So it's another sort of consideration that comes as you're building out these features. At JB&B, we identified a need for personalized environmental control, which led us to develop a personalized ventilation product, which we'll be piloting later this year. But the key point is that we were seeing a trend towards everything needs to be controllable from software anyway. So to add this extra level granularity would take less than you might think. And then further, so like I said, it doesn't necessarily have to be about HVAC when we talk about these sorts of dynamic controls. I believe that as the agency of the occupant goes down, say in an open office environment, or potentially a hospital or an elderly care facility, or even in a school, there's an opportunity and a value, or an extra value, to deliver personalized control, which is one of the sort of really valuable features that a smart building can support. In my own and sort of previous work, I have been involved in the development of personally controllable, personalized AV and lighting systems for to basically support the emotional regulation of children with autism spectrum disorder. So just pointing out that there are a whole host of opportunities where personalized control can be really, really meaningful to the person who uses your building that you're designing. And if we can control our building in all kinds of wonderful ways, and we've implemented all kinds of intelligent integrations to make it work better, it becomes very important to communicate those successes back to the people who use or operate the building, whether that's in the form of dashboards or whatever. But the key ideas, or a key point I want to raise here, is that what is the correct amount of information for one user? Say your F&M team could be completely inappropriate for, say, a tenant. So thinking critically about what information should be presented to different stakeholders can help them derive value and understand value. A good example is your F&M team totally want to know, that a conference room isn't hitting 2,500 parts per million CO2, but your tenant probably doesn't even know what a part per million is and doesn't care. So all they need to know is, one, that you are monitoring that for them, and then two, that you're hitting the target that you set out for yourself. Which brings us to analytics. So it is one thing to communicate and visualize, but the real value of the data which smart buildings can produce is asking questions of our building such that we can figure out how to run them better. So a couple of common kinds of analytics which we get into at JB&B is key performance indicator tracking, or KPIs. And as system designers, this is something which you definitely want to be involved in. Nobody's going to understand how your building should be performing better than the person who developed it. So as you find yourself on smart building project teams, it's important to be communicating what those KPIs should be to the folks who are going to be implementing them from, say, a software perspective. So taking that one step further, if we know what the indicators of success are, then we can get into fault detection and diagnosis, and potentially doing that in an automated fashion. And this can be accomplished through a simple development of rules or profiling over time, which can support, say, prediction and helping us figure out if something has gone wrong, because we can do it by basically figuring out, detecting anomalies, right? And seeing well, this isn't how it typically trends. Something must be wrong here. Someone's got to look into this. I think it is useful to understand what faults are as a counterpoint to alarms. So alarms are, everyone knows what they are, but they're triggered by something anomalous happening. A good example or sort of the urgency with which we might trigger an alarm is, all right, I've got water in a data center that's been detected by a leak sensor. Like, this needs to be addressed right now, super urgent. And it is easy to detect because there wasn't water there before, and now there is. Something bad's happening. Faults, on the other hand, are much more difficult to detect because they are recurring, right? They're persistent. If it happens every day, then it becomes very difficult in an automated fashion to detect that something's wrong. So faults are persistent issues with the way that the building is operating that have an impact on its performance. Examples of causes are things like leaky valves or unresponsive VAV dampers, which may not be immediately obvious from the way that the building is performing that is the cause. And what fault detection generally, as well as automated fault detection and diagnosis, can provide in terms of value is identifying issues before they become emergencies, increasing energy efficiency, extending equipment life, and in addition to that, preventative maintenance obviously costs less than from repairing something that has catastrophically failed. So not just extending the equipment life, but also lowering the operating cost of keeping it going, and then minimizing hot-cold issues, which is something which, of course, your F&M team wants, but also your tenants want it too. So fault detection and diagnosis is a powerful tool, but it can be labor-intensive to set up, especially in big, complicated buildings like the ones that are designed in New York. The reason that is labor-intensive is that for the person who's setting up these sort of software tools and supervisory tools, they need to have an in-depth understanding of each and every building, right down to what points are named and what which points are related to which other points. So as system designers, one opportunity that we have to streamline the process of implementing anomaly detection and fault detection and these kinds of things is to document using machine readable system models. I'll get into two later, but just, no one knows the building better than the person who designed it. So there's a real opportunity to really deliver high quality documentation, which can make the implementation of these sorts of software tools much more seamless. And from a tool development perspective, if all of my buildings, which I manage, have really great documentation, then I'm supporting what you call like software portability, which is to say that if I write some kind of clever fault detector, then I can turn around and apply that to several other more with very little effort, because my underlying schema documentation was thorough and complete and unambiguous. And if you can deliver fault detection and you're able to successfully diagnose things maybe in an automated fashion, then you have much of the raw materials to be doing predictive maintenance, which is, of course, sort of a holy grail for facility management. And the key thing that I would want to impart on this topic is that predictive maintenance isn't a sort of pie in the sky. It is being done on all kinds of systems right now. A good example of which is the Finnish elevator company Kone. They service something like 1 million elevators, and they realized that they were able to capture performance data from all their elevators and get it somewhere central quite easily. But where they ran into issues, even with their small army of data scientists, they just couldn't manage all of that data in a way that was sort of time and cost effective. So they partnered with one of the big tech companies to develop ML models that they could then use to figure out when elevators were going to fail before it happened. Anyway, so it's already happening, and it's something which we can support through good documentation and that kind of thing. And then next, I want to cover the delivery roadmap, and like I said, specifically how it differs from traditional project delivery. The first item here is that you're probably going to see two new team members on your project team rather, the digital or smart buildings consultant, and then the master systems integrator. And I'll go into detail on what they do shortly. Sort of considerations for the delivery of a smart building is that flexibility is really, really crucial. You are going to have several product cycles over the design and construction timeline. So you want to be specifying based on sort of what things should be doing, not necessarily what that specific product is one way to sort of combat the quickness of product turnover. And then it's really useful to be in sort of constant contact with vendors, knowing what is coming down the pipeline, what features will be available towards, say, the end of project completion, such that you can be writing that into your specs at the beginning. Which is also to say that if you can, pushing product selection until as late as possible is really valuable, while being cognizant of the fact that for many smart buildings, you're going to sorry about that. Yeah, for many smart buildings, you're going to have a number of requirements which your particular products are going to have to meet in terms of how they behave on a network and that kind of thing. So just be aware that device qualification can take a little bit of time. It differs from client to client, but it's not something you need to be aware of in your schedule and build that in. And then in terms of schedule adjustments, it is extremely valuable to know who your project team is as early as possible. Of course, there's all kinds of difficulties here with regard to making sure that things are being competitively bidded and considerations of that nature. But the sooner you know who's on your team and the more clearly you can articulate who needs to play with whom and that sort of thing. So the earlier you're making decisions about what integrations are going to have to happen, and the sooner you know who's going to be doing that, the better off you're going to be. In addition, your IT team, whether you have an in-house, whether the project is using an external IT designer or the client has their own, that person or that group wants to be in the conversation early as well. Because when it comes to operating the building, they're going to be the one managing this converged network, so they need to know what's going to be on it and how's it going to behave, how those products will be behaving. And then on a related note, IDF and MDF spaces, they are central to the installation of certain smart building products and certainly the commissioning of many systems when you're deploying a smart building. So your IDF spaces and MDF spaces need to be done early, as well as the cabling, and these have to be online early on in the process to make sure that there isn't a cascade of backlog happening. So the first new sort of member of your project team, as you're going to be working on smart building projects, is the digital building consultant. They report typically directly to the client. It is their role as sort of the design side lead for the smart building aspects of your project to synthesize the client's ambitions, their standards as well as best practices, to distill the specific smart building project goals. Sometimes this results in an actual document, which, depending on where you are, might be referred to as the employer's requirements. But they're going to be producing a bunch of documentation around what this smart building has to do from an integration perspective, what the experiential requirements are going to be, and then they're going to use all that documentation to help bring on board the master systems integrator. So the MSI, or the master systems integrator, they are responsible for executing the smart building from the construction side, or from the construction implementation part of the schedule. So they are going to ensure that the products, well, for one, they're going to probably double check any specs or potentially write the specifications for some of the subsystems, and then they will be responsible for making sure that the products that vendors are proposing to use are going to hit the specs and integration requirements for the building at large. They're going to work with the digital building consultant to make sure that in support of all of our software layer stuff, that we have coordinated point naming and schema documentation. And what their job really is all about streamlining the integration process such that all of our deliverables, like single head-end graphics, fault detection, and digital twin deployments, that they happen in a way that is reasonably streamlined, and try to mitigate the risk of, say, implementing an integration with two things which are not that commonly integrated. So in terms of process, this is the one that we use at JB&B. There's a component of basis of design or pre-design where we map out what the different stakeholders' objectives and goals are, and then sort of profile those as user journeys, which we can leverage to figure out which integrations are going to be required to support those. Sometimes the client does this, but sometimes the DBC does. It's really important that cost-benefit analysis is, well, and in addition, sort of business use cases are really vetted for each technology, because, like I said, it's not about delivering great technology. It's about delivering great outcomes in terms of performance or experience. So just making sure that things are monetarily sound is important. And then working with the client to figure out what are they looking to have integrated and operational day one, and then where is it important for them to have flexibility in the future for adding features and integrations later. Then on the design side, there's of course going to be a data architecture spec, which includes communication protocols, data structures. We want to be documenting at this phase the advanced control sequences, and then any integration, like really fine-grained, what are the integrations we require, how are those going to be accomplished, such that we can leverage the set of documents to both onboard an MSI, and then with the MSI's help, do vendor scope review and selection. So these first two steps are mainly owned by the DBC. The implementation, this is owned by the MSI. They're going to be responsible for making sure that proof of concepts are completed and validate any products and integrations which we want on our project. A lot of clients are probably going to ask that whatever MSI gets picked, that they have some kind of lab facility or sandbox or garage that they can confirm integrations before equipment is purchased, such that we're not doing this on site after all the equipment is purchased and we realize it's a headache and we should have gone with something else. During the implementation phase, we're going to be building out our data infrastructure, including the data lake, which is like a central repository for the data from all of our subsystems, which then will be leveraged to configure analytics, and all of our other software tools, including dashboarding and KPI tracking and commissioning, which, and it's important to note here, there is not just HVAC commissioning that has to get done, of course, but also integration commissioning, which gets started in this lab environment, but then has to actually, we need to see that it is working on site in the building as well. And then for day two, right, ongoing operational optimization. One of the big opportunities that smart buildings afford is developing ongoing relationships with clients after the building gets occupied. The MSI certainly needs to stay on board to support and maintain the analytics software, but I think that there's also an opportunity for designers to system designers to stay on board to make sure that their systems are working as designed, and then perhaps recommending corrective action, even a couple of years down the line, wherever appropriate. So I sort of touched on some of this already, but there's some schedule adjustments that you should try to manage. The first of which is, like I said, if we can push back selecting specific products as late as possible, we can help to ensure we get the most up to date when move-in actually occurs. Granted, and sort of balancing this with device qualification, depending on how slow moving a vendor is and how complicated or rigorous a client's qualification procedures are, this can take anywhere from weeks to months. So knowing what a client hasn't approved in terms of qualification, being aware of how long it might take is really important, such that you're not waiting on qualification to finish, say, commissioning or integrations. And then, as I said, IT infrastructure needs to be in place. IDF, MDF spaces, we want those done early, such that, as an example, if we've got PoE lighting, that those are the racks where appropriate are in place, powered, ready to go. And then from a commissioning perspective, if our, wherever possible, it's encouraged not to be commissioning on a temporary network, because on a converged network, your client's IT department is the one managing that. And if some kind of, if there's like a firewall issue or something which the client is going to implement on their network wasn't on your temporary network, you're not going to know that that's going to cause a problem. So wherever possible, commissioning on the actual final network is really valuable. So all that said, if it's, you really want to target 4 to 6 weeks, have your IDF, MDF spaces and all your wiring done 4 to 6 weeks before commissioning starts, such that if there's a delay, it doesn't cascade throughout the rest of the install and commission process. All right, so then next up, we're going to cover the technologies. So what are they? How did we get here? I'm going to try to be quick here. So there's a lot of them. This, the key thing though is that they don't represent individual data silos or potentially some other head end that your operations staff have to manage. What they do represent is one more data set that can be used to make the other building systems run better. You could make a much longer list of core technologies than this, but in my opinion, these are some of the most important. And I'll dig into each one a little bit. So internet protocols, you'll hear in like marketing sort of driven presentations that the Internet of Things is driving smart buildings. Really, I think internet protocols are, and the reason I say that is you don't even necessarily need internet access to benefit from IP protocols. Analytics and software tools, software supervisory tools need IP based protocols to communicate between systems and to themselves. So there's a real impetus to move away from serial communications where possible. And if there's for some reason you do need to use sort of something that's serial or something a little bit legacy, you just need to put a gateway in front of it such that it becomes accessible. Converged networks, this is, I sort of touched on this earlier, but the idea here is we want to be, whenever possible, putting our IT and our OT on one network. This is going to save you a lot of time and headache when you are bringing systems together and integrating them. And yeah, it'll just sort of simplify the integration process if everything sits on one network. It also simplifies management, so always encouraged. If we're running cables everywhere, then, sorry, we're running cables everywhere. Sorry, guys. Right. Then we, there's an opportunity to leverage power over Ethernet. There are a whole host of services that we can run over one PoE cable. So, which is it's an Ethernet cable. We're running power and data. This started out at about 15 watts. So, we could run devices like IP cameras. And then as sort of the standard grew, then we were able to get, say, we could push 30 to 45 watts. So we could bring online stuff like connected lighting. But now we can, as of I think last year, there were switches which could push, we're able to support 95 to 100 watt devices, which is huge. one fun example that Cisco told us about recently was at a hotel in Chicago, they were able to run PoE mini fridges in a bunch of hotel rooms, which is just sort of an interesting use case. I don't know what the data was, maybe just like what candy bars have been eaten, but in any case, you can do some real work with that much power, obviously. And then wireless, it doesn't, there's a bit of a diminishing return curve when you're talking about connecting everything through wire. And for certain less mission critical technologies, something like occupancy detection, it can save you some money if you're just running it over some kind of wireless protocol. And edge devices. So, there's far too many to cover, but the basic idea is computation is becoming quite low power, meaning we can do complicated things on devices, which is great from like a security perspective, where we can say process video locally and then only be transferring knowledge rather than like raw video feeds to our supervisory programs. And then the cloud. So I think that there's sort of an undue amount of mystery about what the cloud is, but the short of it is, for the purposes of smart buildings, it is storage and services which live on the internet and make data produced by your building accessible from anywhere, potentially. So this is really useful, of course, for if I'm managing portfolio buildings. We've got to rely on the internet for that. I think we're getting a little, I'll run quickly through this. So implementation, here's a quick example of a project we're actively working on, and have done similar ones in the past. But when we are working through the process, how do we deliver a smart service or building? Like I said, we start with identifying who the stakeholders are, what their needs are, and then building out solutions based around that rather than specific technologies. So one of our clients recently was explaining to us that they, in several of their properties, they get complaints about the sort of friction around delivering stuff to tenants, like food or packages. Security didn't want all these delivery people in the lobby potentially, and the tenants don't want to have to come down, especially if it's a big building, to get their delivery. So we identified one possible solution for them, which was robotic delivery, identified what the user experience should be, and then to help them understand what would be needed from an integration perspective, and to help sort of align subsystem vendors and integrators, looking at, if we start with an experience, then what is the integration requirements to make that experience seamless? And then, as I said, sort of with a background in IoT development, openness and standardization is a topic that's near and dear to my heart. So smart buildings are all about horizontal interoperability. And there's sort of a call to action around making sure that the data produced by one system is available to all of the other ones, such that each of those subsystems can be optimized to its fullest extent. And then there's also sort of a requirement to make sure that we're specifying, like as system designers, specifying IP-enabled products which we know can securely and predictably operate on a network, such that our client's IT team can manage those devices. A lot of sort of network security is designed around the fact that an assumption that a device can protect itself on a network. This isn't always true with like IoT devices, so there's a real importance in understanding how those devices need to operate, like from a network management perspective. All right, and then I'll quickly sort of run through this. The best integrated smart buildings use recognized standards, so for everything, like if we can, communication and point naming and schema documentation, in device behavior, this is sort of what I was touching on before, and then API development, or rather having APIs available such that software tools can access data. Communication standards, there's lots of them, but just making sure that the ones that you're using and that vendors are recommending conform to your integration plan and have, are open and standard. Sort of a further reading maybe point is just look up Project Haystack if you don't know it already. It's an open source tagging framework to tag all of your points in a standard way such that software tools can sift through those and in the most recent version infer ontology, which is like the sort of structure of your points automatically with some amount of confidence. And I touched on it a little bit earlier. Machine readable documentation is, I think, in my opinion, really valuable for the future of smart buildings. So making sure that the system is documented in a way which, like say using a schema like Brick, which somebody building portable software tools can just come into your building, add their tool, and it will infer how the building is set up automatically. It's going to save time and ease implementation. And I'll skip the case study just to open us up for questions. Yeah, and again, I'm going to bring back on Gab, who's JB&B's Director of Smart Building, and John, who's an associate and controls expert, to hopefully answer some questions.
All right, fantastic. Thanks, James. It was a great presentation, so really appreciate it. For everyone out there, we have a few questions here. If you have any additional questions, just type them in and we'll try to get them answered in the next 10 minutes. So the first question from James, not you, James, different James. Does the New York State Energy Code effectively require implementation of any smart building control systems? Or is there anything that I should be cognizant about from the Energy Code versus developing a smart building?
So John, unless you want to chime in, I can kind of broad strokes answer that. There's nothing in the code that says like all of your systems need to talk and kind of do the things that James just laid out. I do think that even before the current code, there are more and less effective ways of implementing occupancy-based control and implementing plug control, right, which is already mandated by code. So smart buildings may give you a path to code compliance even before this code that leverages, cheaper edge tech, something that has more user engagement, that actually gets used. As a lot of us know, plug loads often aren't really controlled as the code intends when a building actually gets running. So I think those are the two big things is, occupancy sensing from the lighting. Hey, let's use that data in other places. And then let's actually do switchable receptacles the way it should be. So the short answer is this code doesn't really provide a lot of extra ammunition for pursuing smart buildings. I think, if anything, changing expectations from clients and to some extent, we'll see what happens with COVID, but those are probably the bigger trends.
Yeah, and that's a good segue into our next question. So as procedures are developed for building reopenings, and I'm sure you guys are dealing with many of your clients right now trying to figure out how they're going to reopen their buildings. What are some of the topics that you're discussing with them in regards to monitoring and smart buildings, or any interesting items that our viewers would maybe look into themselves in terms of building reopenings?
Right. I would probably say that one of the most critical is going to be perhaps even more fine-grained than we have been doing with, say, motion-based occupancy detection, like really knowing how many people are in a given space, and it's going to be crucial to understand despite our best efforts, our spaces being occupied in a way that is too dense. But I would say like that's going to be one of the really big ones, is knowing how many people are using any particular space.
I would add to that, you do have a lot more interest now in PM 2.5 sensing from an indoor air quality standpoint to validate that filters are actually doing their job, because now we need those filters to restrict small particles, as well as CO2 sensing, just to maybe even a more fine-grained way, just to verify, yes, you are getting the outside air dilution that you think you're getting, especially from a tenant standpoint.
Right, and that a lot of these systems that we're leveraging that we're looking at for particulate sensing and other things, adding them to the BMS is kind of a hardwired solution, can be expensive, but leveraging them as a separate system through a RESTful API is a much easier solution and a lot cheaper and a lot faster. Leveraging that data lake and leveraging like those IP technologies is going to be huge for getting those technologies in the buildings as fast as possible.
Yeah.
As a slightly less common approach, I think robots to transport things instead of people. A lot of people have a perceived fear around elevators because it's a tight space. And so if we can have robots leveraging those elevators to transport things instead of people, that could be one strategy.
Yeah.
Yeah, I know you've shown us in the past some examples of hospitals using robots to transport materials or samples or whatever it is around the building, which is a very interesting and elegant solution.
Yeah, and I've spoken to a bunch of vendors recently about that. People are like, they're kind of back ordered right now for that purpose.
Oh, really? No.
Yeah.
So we have a couple other questions, and two of these are kind of related. How does the smart building consultant / team typically interface with the MEP design team? For example, is a smart building consultant also responsible for HVAC controls? And how's that related? I think this harks back a little bit to the beginning of your presentation.
Yeah. So
yeah, this is a point of some controversy, right, James?
Yes. Yeah. So it's going to depend on the specific project. And maybe to answer the question specifically of, like, are they absorbing control scope? Probably not. At least, like, definitely not the digital building consultant. You probably still have your separate controls contractor and design team, but what they're going to supplement that with is what the integration requirements are going to be, what the protocols that need to be used for controls are. But they're not typically absorbing anybody's scope. They're just sort of adding a supplemental layer to make sure that things are going to interoperate the way we want them to.
Yeah, that's well put. I think the MEP consultant is really still where the rubber meets the road. So if there is a separate digital building consultant that's not just, like in our case, an extension of the MEP team, that coordination is key, right? Because ultimately a lot of the ideas have to make it into our specs the right way.
Yes. Yeah.
Yeah, that kind of relates to some. There was a question. While Division 23 specs are prevalent and fleshed out, Division 25 seems to be threadbare. Is there work to develop and standardize something? And so maybe just discuss a little bit about where the parts and pieces of a smart building system need to integrate into the specifications.
So for Division 25 is going to be, that's probably going to be where that smart building consultant really lives. And that spec is going to help define the architectures, the communication protocols, kind of like the overarching architecture about what systems are supposed to speak to each other, how they're going to do it, what the cybersecurity requirements are going to be. So a lot of things that are going to be requirements across multiple different systems and should be referenced or included in AV systems, lighting systems, BMS systems, elevator systems, parking systems. You can go on, but keeping a central repository of how all that is going to work together is probably going to be in the Division 25. I don't know of any standardization for it, but I think that's going to be, we'll see that coming, I'm sure, from someone, but.
And then we have time for one more. When the scope is bid out for any smart building devices or the infrastructure, whether it's POE, whether it's Cat6 cabling or the programming or anything, would you expect this to be bid out to the electricians, to the telecom contractor, to the BMS contractor, a combination of them? Do we need to specify that when we issue the design documents?
I think the best strategy seems to be to try to consolidate a lot of the cabling into one package, and then really look for folks who are bringing their devices and their programming chops to the table. So not everybody's bidding in that way. You still have situations where, you know, you've got a BMS guy and you've got an electrician subbed under them where there's going to be a markup. But I think the better route from what we've seen is to try to consolidate the cable package under an electrical scope.
Got it. All right. Well, it's 1 o'clock, so we really appreciate everybody attending. If you have any additional questions, you can email us at ashraenyc@gmail.com, and we can get those questions to the team. And don't forget to fill out the poll after you exit the program so you can get your PDH. So to James, Gab, John, thank you so much, and we'll see you next week.
Have a great one, guys.
Thank you.